Hello, welcome back to Statistics and Mathematics YouTube channel. Today we are going to start our studies on frequency distribution, which is a sub-course in Statistical Method 1. And then, if you haven't watched the video from the introduction to statistics, categorical data, quantitative data, the nominal, ordinal, and then the rest of it, please kindly go back and then watch it before you start the frequency distributions, because we are going to use some ideas from there to really treat the frequency distribution for your own understanding. Yes, so for one to be able to understand what is meant by frequency distribution, one has to be able to understand what is meant by what? Raw data, right? So for instance, in a given study, you want to get individuals who is below 12 years, and the number of individuals or the children that we want is what? 28 in total. And with this 28 total, we want those individuals whose age is less than what? 12, right? Whose age is what? Less than 12. These are the list of what? The data that we have. We have someone who is having the age of 11, 5, 6, 7, 3, 5, 2, 1. Right? This is what the 28 raw data that we have. So if you see this kind of data in your books, internet, on any software or device, this form of data is called what? A raw data. Right? And raw data can hardly give information. Raw data can hardly give what? Information. So what you usually do for raw data is that we represent this raw data on what we call frequency distributions, right? So we represent this raw data on what? Frequency distribution. So what is meant by frequency distribution? We are saying that a frequency distribution is the organization of a raw data in a table form using classes and frequencies. We are just going to organize this raw data, and the formula that we use to organize this raw data is classes and frequencies. So what is meant by frequency? A frequency is the number of times an observations occur in a given raw data. The number of times an observation or particular observation occur in a given raw data. And then classes. These classes can be in the form of what? A given interval. Or these classes can be in the form of what? A given digit. Or can represent what? A categorical what? Value. Right? So that's the meaning of what? These classes. Yes, we have different forms or types of frequency distribution, right? We have what we call categorical frequency distribution, on-group frequency distribution, and then group frequency distribution. But the first on my list, we have what we call categorical frequency distribution. So what is meant by categorical frequency distribution? Categorical frequency distribution is used for a data that is used for data that can be placed in a specific category, such as political affiliation, religious affiliation, major field of what study, and what, etc. So for instance, if a given raw data is given to us, and that given raw data is in the form of what? A category, we use what we call categorical frequency distribution to construct the frequency distribution for that. So for instance, it can be given to us in the form of what? Let's say political affiliation. We have what we call the MPP, the NDC, the CPP, the PPP, the AGC, and the ADC, the MPP, and the many more. So for instance, if this political affiliation is a form of raw data given to us, this is what a categorical data. So we are going to use what we call the categorical frequency distribution to construct the distribution for this raw data. And it can also be given to us in the form of religious affiliation. So we have what we call the COC, that's the Church of Christ, Church of Pentecost, Presbyterian Church of Ghana, Church of Pentecost, Church of Christ, Church of Pentecost, Church of Christ, right? This can be just what? A raw data given to us of a given religious what? Affiliation, right? And this raw data is in the form of a category, and we use what we call the categorical frequency distribution to construct such a frequency distribution, right? And then we can also have what we call the major field of what study. We can have statistics, sociology, economics, land, statistics, actuarial science, and then what? Many more, right? So let's say if this is a raw material given to us. With this raw material given to us, It's in the form of what category, and we can use the categorical frequency distribution to construct a frequency distribution for that one, right? So this is what, and just a small example for a categorical raw data set, right? And then we have this frequency distribution. This is a typical example for a frequency distribution for a category, right? It's a typical example for categorical frequency distribution. Here we have been given our blood groups, and then we have constructed a frequency distribution for that. So here we are saying that for blood group A, we are having 5 individuals who is having a blood group A. For blood group O, we are having about 3 individuals. For blood group B, we are having about 1 individual. For blood group AB, we are having about 6 individuals. So this is a typical example for blood, the frequency for a given blood group. So don't worry, don't panic about how these things are being constructed, right? In our subsequent videos, we are going to treat how this categorical data can be represented on a frequency distribution. I'm surely going to solve an example with you guys, but today I just want you to know how the data will just look like, right? Yes. So let's continue. So we have another one here called a group frequency distribution or group frequency tables, right? Group frequency distribution, they have a range of possible values for a given or a class with its respective frequency, and this form is called a group frequency distribution. So usually for a group frequency distribution, always the max, as you can see here, or the class will always be in the form of a given interval. Like this, we are having from 0 to 20, from 20 to 40, from 40 to 60, from 60 to 80, from 80 to 100, right? And then this is just telling us that within 0 to 20, we have about 7 individual who is scoring within 0 to 20. We have about 5 individuals who is scoring from 20 to 40. We have about 2 individuals scoring from 40 to 60. We have about 9 individuals who is scoring from 60 to 80. We have about 1 individual who is scoring from 80 to 100. So this is a typical example of a group frequency distribution. So what make a group frequency distribution is that always for the max or the class, we are going to have what you call we are surely going to have what you call an interval, right? It's surely going to be in a given interval, right? And the next frequency distribution that we have on our list is on group frequency distribution. So for on group frequency distribution here, if the range of data, right, data value is relatively small, a frequency distribution can be controlled by using a single value. So for instance, if the given interval given, right, the range between them is very small, like 0.001, right, as that give the length for the given interval, we can just reduce it to a single digit, right? So for the max or the class size, it's just going to be a single digit, as you can see here. So here we have 8, 4, 10, 12, 11, and 5, right? These are the ages, right? And these are its respective frequencies, as we can see here. So this is also a typical example for on group frequency distribution. Always what make on group frequency distribution and on group frequency distribution is that always the class size or the classes will be represented by a single digit. This will not be represented within a given group, right? It will always surely going to be a given digit. So in our next video, we are going to learn how we can construct a categorical frequency distribution, on group frequency distribution, and then group frequency distribution. So kindly stay tuned, and then if you haven't subscribed, like and share. Please kindly subscribe, like, and share, and leave your comment at the comment section below. This is Statistics and then Mathematics Tutor channel. Make sure you leave a comment and subscribe. Bye.